This is a solution video for the mock for differentiation rules. First it says to set the function f equal to cosine x divided by sine x. Part A says use the quotient rule to calculate and simplify f dash of x. So they want us to find the derivative, right? This is one of the ways they can say derivative. They could also say y dash. They could say dy dx. In this case, they said f dash. They said to use quotient rule. So quotient rule, remember, if you copy it from the formula booklet, looks something like v squared on the bottom, and then it says like du dx times v plus u dv dx. Some people might prefer to write it as vu dash. Oops, I'm sorry. I made a mistake. Be careful when you copy from the formula booklet. So there's a minus there, right? And u dash v, uv dash. Okay. And then on the bottom v squared. Okay. I usually write it with the dashes because it's quicker. Okay. But don't get intimidated by the fact that there are these little x's here. The x just means they take the derivative with respect to x, which almost 100% of the time we do. Okay, so this is the quotient rule, and all I need to do is substitute in the two parts of my quotient. The top part of my quotient is always going to be u, and the bottom part of my quotient is going to be v. I'm just going to write them down here. So u equals the cosine of x, v equals the sine of x, and then I'm going to take the derivative of each one. If I look in the formula booklet, the derivative of cosine x is negative sine x. The derivative of v or sine x is going to be cosine x. Check that in the formula booklet. Don't just rely on your memory. And then I'm going to, multiply the appropriate ones times each other. So I'm going to do a direct substitution. First, I'm going to do v and u dash. So I'm going to do sine x times negative sine x. That would give me negative sine squared x. For those of you who are not familiar, if you put a 2 right next to the sign like that, it's the same thing as writing sine x quantity squared. Okay, negative sine squared x, and then I'm going to do a subtract, right? Subtract, and then I put the u, which is cosine x, and then I'm going to multiply times v dash, which is also cosine x. So I'm going to square that too. And then on the bottom, I'm going to put v squared, which would be sine squared x. Okay, so here is my initial answer, and it says to simplify. And so in this case, normally we don't simplify, we don't worry about simplifying that much, but if you look below in part B, it's going to ask me to take the second derivative, and before you take the second derivative, it's a really good idea to simplify the first derivative so that it makes your life easier. How can I simplify this one? Well, since we're fresh off the trig unit, you might recognize the top as having a sine squared and a cosine squared, subtracted instead of added. But if I factor out a negative 1, look what I have now. On the top, I have sine squared x plus cosine squared x. And if I look at my formula booklet, that is the Pythagorean identity. It's equal to 1. So actually this yellow part here is equal to 1. So I can substitute 1 in there, and so basically when I simplify this, it's negative 1 over sine squared x. So that's the first derivative. Now it asks me to find the second derivative. Notice there's like 2 dashes there. Another way they might write second derivative would be y dash dash. Another way they might write it is d squared y dx squared. They want us to take another derivative of this time of this function. So if my f dash is negative 1 over sine squared x, I want to take the derivative of this. First thing I want to do is probably rewrite this as something that has a power in the numerator, because you might say use quotient rule, but look at the top. Is there an x in the top? No. So quotient rule is kind of overkill. So let's rewrite this. I'm going to rewrite this bottom part here, sine squared x, as a power, a negative power. Okay, so I'm going to put -1, which is the coefficient on the top, and then I'm going to rewrite sine squared x, which remember is the same thing as sine x parentheses squared. I'm going to rewrite this as a negative exponent and put it in the numerator. Okay, see what I did there? Now that I rewrote f dash of x, now I can more easily take the derivative using chain rule and power rule, right? So this is something where I can use chain rule. I have an outside function, which is to the -2 power, and then I have an inside function, which is sine x, okay? So remember, to take the derivative, I am going to just write again the coefficient. You don't do anything with coefficients. I bring down the -2 exponent, and I leave the inside the same, and then I deduct 1 from the -2. It becomes -3. And then I leave the inside the same, right? And then I'm going to do chain rule on the sine x, and that the sine x becomes cosine x. Now I can simplify a little bit. The -1 times the -2 becomes +2. And then if I want to, I could write the sine x in the bottom again. So this is the numerator and this is the denominator. I'm going to put sine x to the cubed. Okay? So if I want to, I could write it as 2 cosine x divided by sine cubed x. I use that notation where I put the cubed right next to the sign, and then I don't need to put parentheses. Okay, so that was the second derivative. Then in part C, it asks me to substitute in pi over 2 for the first derivative, and then it asks me to substitute pi over 2 in the second derivative. So if I put pi over 2 in the first derivative, let's see what I get. So it's -1 sine squared is the first derivative. -1 over sine squared. And I'm going to put pi over 2 in for x. So that's going to be -1. So I'm going to do that. I'm going to put pi over 2 in for sine. And pi over 2, remember, is 90 degrees. Sine of 90 degrees on the unit circle is this position here. So the y-coordinate of this position here is +1. So basically I have -1 over +1 squared, which is just 1 on the bottom. So the whole thing is equal to -1. So the first derivative with pi over 2 substituted in is just -1. That's that one. Let's do the second derivative. So the second derivative, remember, is this. So we're going to put 2 cosine x divided by sine cubed x. That is our second derivative. And then what we're going to do is we're going to put in pi over 2 for the x value. So it's going to be 2 cosine pi over 2 divided by sine squared pi over 2. Cosine pi over 2, right here, that is equal to the x-coordinate of this position here, so it's 0. So the top is 0. And the bottom, sine squared pi over 2, remember that's just +1 because it's this position y-coordinate, so it would be 1 squared on the bottom. So basically it's equal to 0. So this expression here is equal to 0. So the first derivative is -1 and the second derivative is 0. Okay, number 2. This time we have a function which is x cubed times natural log of 4 minus x squared, and then they give us a domain which is between -2 and 2. We can talk about this domain a little bit later, but it's not really important to doing the derivative. We're going to find the derivative because find dy dx means find the derivative. They could have also said find y dash. They could have also said differentiate. Okay? Differentiate is the verb form of derivative. Derivative is a noun, differentiate is a verb. Let's take the derivative of x cubed times natural log of 4 minus x squared. When you look at this, you say, okay, do I use chain rule? Do I use product rule? Do I use quotient rule? In this case, you can see that you have something times something. So we're probably going to do product rule. Remember, product rule is written as the derivative of uv is uv dash plus u dash v. Doesn't really matter which order you put it in because 2 plus 3 is 3 plus 2, right? For quotient rule, it does matter which direction you do it because there's a subtraction sign. But for product rule, it doesn't matter. So u is equal to x cubed, and v is equal to natural log of 4 minus x squared. U dash is equal to 3x squared. V dash is equal to derivative of natural log of 4 minus x squared, which is not easy. First thing we're going to do is the natural log of something, the derivative is 1 over something. So we're going to put 1 over something, which would be 4 minus x squared. When we do chain rule, remember the inside function, 4 minus x squared, is not going to be changed. We did this part here. Then we're going to do chain rule of the inside. The chain rule of the inside, we're going to take the derivative of the inside and multiply it in a chain link here at the end. The derivative of 4 is 0. The derivative of negative x squared is negative 2x. So our simplified expression would be negative 2x divided by 4 minus x squared. Okay, so we got this, and we got these two. And then we're just going to do product rule, which means we're going to multiply these across from each other and we're going to add them together. So we'll have x cubed times negative 2x, 4 minus x squared, and then we'll have 3x squared times natural log of 4 minus x squared. And we could simplify a little bit because if you look here, the numerators here, we can combine those. We could have negative 2x to the 4th divided by 4 minus x squared. And then this one here, we can't really do anything with that. We just copy it here. Okay. Talking about the domain, x is between negative 2 and 2. Why do you think they have this domain? Remember that there's some values which you cannot put inside natural log, right? Natural log only graphs for the right side of the plane, right? Numbers above 0. Does it include 0? No, because at 0 there's an asymptote. So basically, the input to natural log has to be positive numbers, not even 0. So notice that there's a 4 minus x squared here. Depending on what value I put in for x, this thing could become a negative number. It turns out that the values you can put in here without 4 minus x squared becoming negative are the numbers between negative 2 and 2. And that's why this domain is here. It doesn't really affect us in the problem that we're doing now. Okay? But, you know, in math, they need to be rigorous. They need to show every single detail about what values are permitted. Okay? So, that was it. This is our answer for the derivative of that function. It's a challenging product rule, chain rule problem.